Now, let's try understanding how we actually arrive at these numbers like we discussed a little while earlier. If you're looking at something of this sort, the number of sets here is in this column. We are looking at 2 sets, 3 sets and 4 sets. We can always extend it to 5, 6 or even 100 sets. But let's understand the logic behind how we arrive at these numbers. Now, when you are looking at now 2 sets, the number of exactly 1 regions would be 2. There are exactly 2 regions which indicate exactly 1. Likewise, exactly 2 regions is just one shaded part. This is 1. Since it is only the number of sets being 2, the number of exactly 3 regions don't exist, exactly 4 regions don't exist, and we know that there is one none region in our universe. So when we add up all these numbers, 2 plus 1 plus 1, that's how we get the total number of regions as 4. Likewise, when you look at 3 sets, for 3 sets, the number of exactly 1 regions would be 1, 2 and 3, exactly 3 regions. How do we arrive at exactly 2 regions? Those are these parts. They are again 3. Exactly 3 regions would be just one part, this shaded part, this is 1. Since it is only 3 sets, exactly 4 will not exist and there is one none region. So the addition of 3, 3, 1 and 1 gives us 8 as the total number of regions. How do we arrive at values of this sort when you have higher order sets? Now understand what exactly we did here to arrive at these numbers. If we understand that part mathematically, you will be able to understand and derive things for higher order sets. When we talk about exactly 1, what we did here is we chose exactly one space out of the given 2 sets, and this can be done in 2C1 ways. That is how we get the number of exactly 1 as 2 spaces. If you are saying exactly 2 regions, we are saying select exactly 2 out of the given 2 sets, and this can be done in 2C2 ways. That is how it is 1. Exactly 3, exactly 4 don't exist. Number of none regions means do not select anything from the given 2 sets. That is how it is 2C0. So the value 4, which is the total of all these, is nothing but 2C0 plus 2C1 plus 2C2, so forth and so on. Likewise, the number of exactly 1 regions for 3 sets is 3 because we are choosing any one space at random out of the given 3 sets. That can be done in 3C1 ways. That's how you get 3. Likewise, this 3 is again choosing 2 out of the given 3. That can be done in 3C2 ways, which is again 3. Exactly 3 means 3C3. Exactly 4 doesn't exist. None is simply 3C0. So the total 8 is nothing but the sum of 3C0, 3C1, 3C2 and 3 choose 3. That's how you get 8. So this logic will tell you now how to identify the number of spaces when you have higher order sets. So when you say 4 sets, logically speaking, you're choosing exactly 1 out of the given 4 sets. That can be done in 4C1 ways. So this value must be 4. So you have 4 exactly 1 regions. Needless to mention, when you jump to the number of none regions, this value will always be 1 no matter how many sets you have, because you're choosing nothing out of a given number of sets. 4C2 would give you the number of exactly 2 regions. So 4C2 would be 6. So you would have 6 regions for exactly 2. And then for exactly 3, you will have 4C3, which is 4. So you should have 4 exactly 3 regions or overlaps like we discussed earlier. For exactly 4, you choose all the 4, you will have exactly 1 region. So sum of 4C0, 4C1, 4C2, 4C3, 4C4 is what will give you as the value 16. So this is how we have actually arrived at this representation of how many total spaces we will have. So we have sort of reverse engineered and understood how to break these, slice and spice these to understand that number. So in our earlier representation of 4 sets for circles, if you had counted them, you will have to actually do a little bit of groundwork there, take it as an exercise and do it with circles and see if you've got these kinds of spaces as overlaps when you have represented circles this way as 4 sets. Once it doesn't satisfy it, you know that this is not a right representation. Then what is a right representation? Let's understand that.